So this video is on Integrated 3, Chapter 2, D-Day number 3. So on this, you want to be able to recognize the locator points on all of these. So on this first one, this is kind of that S shape. It's a cubic graph, and it has a locator at -3, -2. So I'm going to go to -3, -2, and I'm going to put my point. And then from here, if you want to think about this and draw it more accurate, what you're thinking is, okay, I am cubing, right? So if I go over 1 from this, okay, let me just get my, if I go over 1 from this, what's 1 cubed? 1, so I go up 1. And if I go out 2, what's 2 cubed? 8. 1, 2, 3, 4, 5, 6, 7, 8. Then, and let me just kind of highlight this point here, because that was my critical point. Okay, so I kind of remember where it was. And then I come back here and come to this inflection point, and instead of going positive 1, let's say I go -1. Well, -1 cubed is -1. If I go out -2 from it, -2 cubed is -8. So 1, 2, 3, 4, 5, 6, 7, 8. -8. And then I am going to connect it with a curve. Think of it as an open down half of one parabola to a half of an open up. That's how I think about it. On the next problem, this is a square root graph, and its inflection point is going to be 4, 1. And so I am going to go to 4, 1. So 1, 2, 3, 4, 1. And then from here, there is a negative in front. So I'm going to take square roots. I'm going to go out 1. And the square root of 1 is 1. And then times it by a negative. So I get -1. From here, I'm going to go out 2. 1, 2. Actually, I'm going to go out 4. 1, 2, 3, 4. So square root of 2 is 1. Okay, the square root of 4 is 2. So I normally go up 2, but because of that negative, I'm going to go down 2. Okay, and then I could go out 9. And then the square root of 9 is 3. And I times that by a -1 and go down -3. I can't do that because I'm out of space on my graph. And then it goes like this. So let me just highlight it here for a second. This point right here, that is your start. There's no arrow there. That is where it starts. Starts there. Okay. On letter C, this is an exponential graph. And if you want to think about it as having a locator point, it's going to be 2, -5. But that's really going to help me kind of figure out where to go to start my graph. Okay. And my asymptote, I'm going to have a horizontal asymptote of y equals -5. So I'm going to go down to y equals -5. And it's really a dashed line. I'm just going to draw a solid line right now, just so it's there. You go. You guys can see it. So this is y equals -5. That's my asymptote. That's the line that my graph is closer and closer to, but never touches, never crosses. Then I'm going to come here, and I am going to go to this 2, -5. So 2, -5. I'm going to put a point right here. It's not a point on my graph, but this is where I want to start my graph. Okay, this is like my 0, 0 right now. So at this point, when I have any exponential graph, you want to identify if you have an A and a B. So my B is the number being raised to the power. So my B is 3. Your A would be what's in front of it times it. I don't have anything, so that's a 1. So what happens then is at that point I did in purple or pink, that's not, again, actually part of my graph. What I'm going to do is I'm going to come to that point, okay, which is I'm on the asymptote at -5. I'm going 2 over, so I'm at 2, -5. And that's where I'm going to go A away. And my A is 1. Whatever my A is, that's how it's kind of like my start, my y-intercept, if it had been up to the origin. So I'm going to go up 1. Then I'm going to go over 1. And because my B is 3, that means I'm timesing by 3. So if my first one I just plotted, that first orange point was 1 above. 1 times 3 is 1, 2, 3. So now I'm 3 above. And then I times by 3 again. So that's going to be 9. So 4, 5, 6, 7, 8, 9. And if I times by 3 again, it's going to be 27. That's going to be too big. Can't fit that one on my graph. And then I'm going to draw it. And it comes and it gets closer and closer and closer to this asymptote, but never crosses it. Okay. On D. So on D, this is a circle. And this has a center at 1, 1. And the radius is going to be whatever the square root of 25 is, which is 5. Okay, because your circle equation equals radius squared. So I am going to go to, let me just put my, like a little thicker one I just, I'm going to go to 1, 1. Okay, that's my center. Now that's actually not on my graph, it's a center of my graph. Okay, and then from here, I'm going to go out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I can draw my circle. Now I'm going to grab my circle shape. Okay. Make it a little see-through so you guys can see the point still. Okay. And I'm going to hold shift, because if I hold shift, it makes it be a circle. If I don't hold shift, it makes it like an oval, or what we call an ellipse. So I'm going to hold shift. I'm going to start at one of these points. And I'm going to start dragging it until that's my center is actually at my center. And there's my circle. Again, don't have to, you can just draw a circle if you prefer. On the next one, this is a reciprocal function. And for this reciprocal function, if you want to think about a locator point, what makes the denominator 0 is -2, and then the 4. So this graph's being moved to the left 2 and down 4, which means I have a vertical asymptote at x equals -2, because that makes my denominator 0. I mean, yeah. And then I have one at y equals 4 for my horizontal, because these actually had 2 asymptotes. So the one that used to be x equals 0 gets moved to the left 2. The one that was y equals 0 gets moved up 4. So again, I'm going to draw them in as a line instead of a dashed line, just so it's not as messy looking. Okay, so that is my x equal -2. And then I have y equal 4. And now, because my A is 1, you really are thinking, hey, what 2 things multiply to get you 1? That's really what we're graphing. So as I'm thinking about that, I'm going to go, okay, well, start here, pretend like this is my 0, 0. I go out 1. 1 times what gets me 1? 1 times 1. If I want to go out 2, 2 times half. 3 times a third. 4 times 1/4. But if I went the other direction, I want a half. 1/2 times 2, for example. Here, make it a little better. And I would do the same on this side. So if I go -1 times a, -1 makes a positive. And -2 times a, -1/2 makes a positive 1. And -1/2 times a, -2, and so forth. And this is where I get my 2 branches. Okay, let me just zoom in a little bit. And so I'm going to have 1 here, and I'm going to have another here, and that's our graph. On letter, on number 2, sorry. No, I've got one more. Thought I did. Letter F. So this one is an exponential graph. I mean, exponential graph, absolute value graph. And we have a vertex or locator point at -1, -1. And then this this -2/3 is your A, your stretch, but it's actually for these, because these are linear, it's actually your slope, okay? So I am going to go to -1, -1, midpoint. And then from here, I'm going to go down 2, out 1, 2, 3. Down 2, out 1, 2, 3. Down 2, out 1, 2, 3. I'm going to do the same on the other side. Down 2, out 3. Down 2, out 3. Down 2, out 3, and so on. And let's see. Then I'm going to connect it. I'm just going to grab the line. Okay. And so here and here, and then that's your absolute value. I'm just going to make this a little fainter so we can see through it a little bit. And I'm also going to give an arrow on, it's not that end, this end, okay? And I'm going to do the same here because these do go on forever. So I'm going to make it a little fainter, and I'm going to put an arrow there. And that's your graph. On number 2, these ones, we want to come up with the equation. And it's said in the directions that if it doesn't give you a point, assume your A is 1. But on some of them, I'm going to show you like how you could figure it out if you had to. On letter A and on letter C, they did not give us a point. So we're going to assume that it's a 1. And actually, they didn't give us a point on any of these, but I'm going to show you how you could figure it out just in case you had to. Okay, if they didn't say your A was 1. So this is a reciprocal function. So this is going to be y equal A over x minus h plus k. And so the two things you want to find is your vertical asymptote, okay, which is at x equal -2, and your horizontal asymptote, which is at y equal -3. So those are going to be your h and your k. So I'm going to go y is equal to A over x plus 2 because of the -2, and then -3. And then to find your A, what you would do, I'm just going to grab this little hand here, is you would come to where your asymptotes kind of form like a little XY axis almost. And if I go out 1, I went up 1. So 1 times 1 is 1. So my A is 1. And my A is 1. That's how you could figure that out. Okay, so my A is 1. And that's my answer. On letter B, what you would do on letter B is this is a absolute value, so it's going to be y is equal to A times the absolute value of x minus h plus k. And so I need to find my vertex, which is at 0, -5, and that goes in for my h and k. So I know I'm going to have y is equal to A, and then because of the 0 going in for my h, this is just going to be the absolute value of x, and then -5. Now, again, it says if they don't give you a point that your A is 1, but if you're looking at this, how you can figure this out is really this is like a line. So if I look at the slope, up 1 over 1, up 1 over 1, up 1 over 1. So 1 over 1 is a 1. So that means this is going to be y equal 1, or just plain old absolute value of x minus 5. And that is our equation. Now, if there was a point, I would be putting it in for the x and the y. Okay. This one here is a cubic one, which is going to be y equal A times the quantity x minus h cubed plus k. And I want to see where it changes from being like an open down to an open up. And that point is right here at 2, 1. So that is my inflection point. So I'm going to have y equal, let me just make my blackboard. Y equal A times the quantity x minus 2 cubed plus 1. And then again, if they had given us a point, I would put it in for my x and my y. But in this case, what I'm going to what I could also do is just think about, okay, let me grab the hand again. If I come here and I go out 1 cubed should be 1. 1 cubed is 1. So that means my A is 1. Okay. If I went out 1 and I went up 5 or something, then 1 cubed is 1. I would have times it by 5. My stretch would have been 5, for example. So this is going to be y equal x minus 2 squared, 2 cubed plus 1. Okay. On domain and range. So domain and range. Domain are your x's, range are your y's. So if you're looking at this graph and you're trying to figure out your domain, what I've been doing with my integrated ones is this is what we have been doing. I've been having them draw a line, okay? I'm going to choose a color that I can kind of see through, and I made a little transparent too. And so if I hold shift and I draw a vertical line, I'm going to use that for domain. And let's say I get an orange one and I draw a horizontal line. I'm going to use that for the range. And how I have them use it is we come over here after we draw it and we come to this little select arrow, and you can take this and you can literally move it. So domain is if you're going across your graph, what's the furthest to the left your graph goes? What's the furthest to the right this graph goes? And you don't want to say it stops here or here because the grid ends, because this is going to continue. Oops, let me grab it. This is going to continue up and out and up and out. So as I keep going up and out, what's going to happen is this, let me grab it one more time. This is going to go across and it's going to keep going forever and ever to negative infinity and forever and ever to positive infinity. So my domain, and this is what my domains are for all open up and down parabolas. My domain is going to be negative infinity to infinity with open brackets. Or you might also do the all real numbers. Now my range are my y's. That's how high and low my graph is. So if I come and grab this horizontal one, and I'm going up and down. So what's the lowest my graph goes? For the lowest my graph goes, it stops here at -1 and it touches at -1. So that's going to be closed at -1. And it keeps going up and up and up and up forever and ever. So that's going to be infinity. Okay. So I'm going to have closed bracket at -1 to infinity, open bracket. Okay, now for this one, if you're thinking about this graph, and I'm just kind of sketching it, I have that 12 on top, which really you would want to think, hey, what two things multiply to 12? So I'd be applying things like 1, 12, and 2, 6, and 3, 4, and 4, 3, and 6, 2, and 12, 1, and -1, -12, and -2, -6, and so forth. But I'm just going to sketch. So if I'm just sketching this, okay, this will be a very rough sketch. I'm going to, whatever makes this 0, which is going to be 5, I'm going to have an asymptote here. So this is going to be at x equal 5. That's where I don't have graph. And then if I had a plus anything here, well, it's really a plus 0. So that means my horizontal asymptote is right here on the x-axis at y equals 0. And here, I'm going to make these a little see-through so that we can see that there was something underneath it. It is the asymptote. I mean, the x-axis, okay? So you can kind of see it over it. So then my graph is going to be here and here, because it should be a positive times a positive to get a positive, and the negative times a negative, if you want to think about this almost like this is a quadrant 1 and this is like a quadrant 3. So that's my graph. So what does that mean? Well, if I get these, let me just grab these real quick, sorry. Should have brought them over with me. So I'm going to grab this and this. Try one more time. Okay.
So if I'm looking at my vertical line in here, maybe let's make it not green so that we can see the difference. So let's say I make it purple. Okay. So as I bring this is my domain. Okay. So as I'm coming across my graph, it's going to keep going forever and ever and ever and ever and ever to the negative infinity. Okay. So as I'm going negative infinity, okay, I'm coming back. I've got graph until I get to 5. No graph at 5. But after 5, I have graph forever and ever and ever and ever and ever. So the way I would write that, my domain is going to be negative infinity, open bracket, to 5, open bracket, union. And let me just scooch this out a little. I don't know why I'm writing on top of my graph. Okay, give myself some room. Okay, and then it's going to be union because I have 2 pieces. So I need to give both of the pieces. And so the other piece is going to be from 5, but not including 5. So it's a parenthesis, not a closed bracket, to infinity. So this basically means everything but 5 is my domain. Now my range is my up and down. So if I grab this orange one, okay, and as I'm moving it, okay, the furthest this goes down is forever and ever and ever to negative infinity. But as I come back up, I have graph until I hit 0. Then after 0, I've got graph until infinity. So it's basically everything except 0. Okay. So this is going to be open parenthesis, negative infinity to 0, union, open parenthesis, 0 to infinity, open parenthesis. And so that is going to be everything basically but 0. Okay. Backside. So on the backside, this one here, the equation of a parabola is y equal a times x minus h squared plus k. And the vertex is going to go in for my h and k, for my h and my k. So I am going to have y is equal to a times x plus 3 squared plus 1. Now, to find my a, I need to use the point that they gave us. And that's going to go in for my x and my y. Okay, so that's going to go in for my x and my y. So I'm going to have negative 1 is equal to a times negative 2 plus 3 squared plus 1. And now I'm going to work this out to find my a. Let me just get black. Okay, so it's going to be negative 1 is equal to, and in my parenthesis, I have a negative 2 plus 3, which is a 1. And 1 squared is 1 times a is a plus 1. I'm going to minus 1 from both sides, and I get a negative 2 is equal to a. So my equation, y is equal to negative 2 times a quantity, and then I'm going to basically use this for the rest of it, okay? So x plus 3 squared plus 2. That is your equation. Okay, on the next one, we're going to be drawing a picture. We have an egg tossing contest, okay? I'm going to start the toss at 0, 0. So this point here is 0, 0. It's going to land 50 feet away. So I'm going to have this be 50, 0. And it's going to be an upside down parabola. And halfway will be the vertex. Okay, and that max height is 20, and halfway between 0 and 50 is 25. So it's going to be 25, 20. So my equation is going to be y equal a times x minus h squared plus k. So I'm going to have, in place of my h and my k, I am going to have a minus 25 and a plus 20. Then to find my a, I'm going to take one of these 2 points, and I think probably the easiest point would be 0, 0. And so I'm going to put that in for my x and my y. So I'm going to get 0 is equal to a times 0 minus 25 squared plus 20. And I'm going to work that out. So I'm going to have 0 is equal to, and when I do 0 minus 25, I get a negative 25. And a negative 25 squared, if you put in your calculator, is 625. So I'm going to have 625a plus 20. I'm going to minus 20 from both sides. And then I'm going to divide by 625. So I get a negative 20 over 625 is equal to a. Now, I could put this in a calculator and reduce it, okay? But I'm just going to leave it right now. So this is going to be y is equal to negative 20 over 625. And you don't need to give it to me as a decimal. Times x minus 25 squared plus 20. And that is our equation. On C, okay, we want to put in a nice graphing form. So I'm going to complete the square. So first thing I'm going to do is I'm going to take that 2 to the other side. I just like to get rid of it, so I'm not focused on it. Okay. And then what I want to focus on is my 8x, okay? Really the 8. I need to split that into an even amount, okay? So we call that our b. So I'm going to take our b and divide it by 2 to get half of it and then square it. So half of 8 is 4 and 4 squared is 16. So that's what I'm going to add to both sides. So I'm going to have f of x minus 2 plus 16 equals x squared plus 8x plus 16. I'm going to add it to both sides. Now on the left side, I'm going to have f of x plus 14 is equal to, and when I do this, I'm going to get something squared. So this is going to be x plus, and then look back at half of our 8. Half of 8 is 4. That's what goes here. And then my last step is to minus the 14. And that is our equation. Okay. Even, odd, or neither. So what we want to pay attention to is we put in a negative x. And if I get out the same as the original f of x, that means it's even. And if I put in a negative x and I don't get the same, but I get the opposite of the original, that's going to be odd. And if neither one of those happens, it's neither. So I'm going to go f of negative x is equal to 5 times negative x to the 6th plus negative x to the 4th plus 9. And what you want to pay attention to is understanding that when you take a negative number to an even, you get a positive, because a negative times a negative is a positive. If you take a negative number to an odd, you get a negative, okay? So when I'm working this out, I am going to get that f of negative x is equal to, now a negative x to the 6th power is x to the 6th. So this is going to be 5x to the 6th. And a negative x to the 4th power is going to be a positive x to the 4th plus, sorry, that was a minus 9. I don't know why I changed it. It was a minus 9 in the problem. So the minus 9 stays a minus 9. Okay, so so there. So now what I want to do is I want to look at what I just got and the original and kind of see, hey, what's happening? So the original was this. This one is the same. So that's this situation where I'm going to end up with an even because I got the same thing back. So this is even. But I need to see work. I can't just see you write the final result that I have highlighted in blue. You need to show me what I had in black with the green highlight. I need to see that what you did. And then you're going to give me an even, odd, or neither. Okay. This is review from integrated 1 in the sense of systems of equations, but really integrated 2 because we did them with quadratics. So both of these are y equal, so we can use equal values. So I'm literally going to take 5x squared plus 2x plus 5 and set it equal to 4x squared plus 3x plus 25. Okay. And then when you have quadratics, you want everything on one side, 0 on the other. So I'm going to subtract 4x squared from both sides, getting an x squared. I'm going to minus 3x from both sides, get a negative x. I'm going to minus 25 from both sides, and I'm going to get a negative 20 is equal to 0. So now I'm going to see, hey, can I factor this? And I can. What multiplies to negative 20 and adds to a negative 1? Well, that's going to be a negative 5 and a positive 4. So I'm going to get x equal 5, and I'm going to get x equal negative 4. So when you have two parabolas, they can meet in two spots. That's what's happening here. So I'm going to have 5 comma something as one answer and negative 4 comma something as the other answer. So I am going to put 5 into one of the equations. Let's say I put it into this one. And then I'm also going to put negative 4 into it. So when I do that, I can do it on my calculator, but here, let me just do the math here. So I'm going to have 5 times 5 squared plus 2 times 5 plus 5. So 5 squared is 25. So 5 times 25 is going to be a 125 plus 10 plus 5. So I'm going to get 135 plus 5. So I'm going to get 140. That's a 0. Trying to erase. Okay, and when I put it into the negative 4 in, I'm going to get 5 times negative 4 squared plus 2 times negative 4 plus 5. So negative 4 squared is 16. 16 times 5 is 80. Minus 8 plus 5. So really that's going to be 80 minus 3, which is going to be a 77. Yeah, 80 minus 3. So this is going to be 77 for this answer. Okay, so 5 comma 140 and negative 4 comma 77. Okay, so now this bottom section. Okay, so on this bottom section, when we are doing these complex numbers that we're multiplying, I'm going to do a box. And I'm going to go 1 minus 2i and 1 plus I. And the one thing we want to remember is that I squared is equal to a negative 1. So you're never going to give me I to a power. So 1 times 1 is 1. Here I get a negative 2i. Here I get an I. And here I get a negative 2i squared. Now, this negative 2i squared, okay, that I can simplify because negative 2 is multiplying with I squared, and I squared is a negative 1. So that is really a positive 2. Okay, so this is a positive 2. So then when I do my math, I'm going to get 3 minus I, and that is my answer. Okay, on B. So this is where we want to simplify these radicals. We cannot add radicals that are different. They have to be the same square roots in order to combine them. So I'm going to take a 24 and break it down to prime. So this is a 6 and a 4, which is a 3 and a 2 and a 2 and a 2. And so I'm just going to circle my primes. Okay, they're all down to primes. And I want squares. So that means I want pairs. So I have a pair of 2s with a 3 and a 2 still left over. So that pair of 2s means that a 2 is going to come out. And then I am going to still have underneath a root 6 because 3 times 2 is 6. Minus and I have a 2 in front of my other one, 2 times, let's see what I get when I do my 54, okay? So when I do my 54, this is a 9 and a 6, which is a 3 and a 3, and a 3 and a 2. So I have a 3, 3, 3, 2. And again, we're looking for pairs. So I have a pair, and let me do it in a different color. I have a pair of 3s. So that means I have a square coming out that was a 3. So I have a 3 coming out. And then what is going to remain underneath my square root is my root 6, because I have a 3 times 2. So now let me clean this up. I have a 2 root 6, and then my 2 and 3 are going to multiply, and I get a 6 root 6. Now they're both root 6s. So if I have 2 root 6s minus 6 root 6s, I get a negative 4 root 6 as my answer. Okay, last 2. So on one like this is from integrated 1. When you're trying to get the same base. So a 4 to not a nice power is going to be 32, because 4 squared is 16, 4 cubed is 64. That's too much. But I can break down my 4 and my 32 to both 2 to powers. So 4 is really a 2 squared, and 32 is a 2 to the 5th. Okay. Now my 2 squared, which is a 4, fancy 4, is being raised to the x plus 2, equals 2 to the 5th. Now I have both of them being the same base. And so when I have a base to a power raised to a power, power to power, I say, we multiply the power. So this is going to be 2 raised to the 2x plus 4 equals 2 to the 5th. And then we're going to solve. And how do we solve? Since they're both the same base, that means the exponents have to equal each other. If one side is 2 to the 5th and the other side's 2 to something, that something has to be a 5. So I'm going to take 2x plus 4, set equal to 5. I'm going to subtract my 4. I'm going to divide by my 2, and my answer is 1/2. Okay, on number 9, this is integrated 2. Hopefully you recognize this is a difference of 2 squares, because I have a 9x squared, which is a square, minus 25, which is a square. So the square root of 9x squared is going to be a 3x, and the square root of a 25 is a 5. One of them is going to be a plus 5. One of them is going to be a minus 5. That's why I don't have a middle x term. So now, by the zero product property, which means when I multiply two things together and get 0, one of them or both of them have to be 0. So I'm literally going to take this and set it equal to 0. And so I'm going to get 3x equals -5. So x equals -5/3. So that's one answer. Then the other one, I'm going to take 3x minus 5 and set equal to 0. I'm going to add 5 to both sides. I'm going to divide by 3. And so I get a +5/3. And those are our answers. So hopefully this video is helping.